The quest for our origins. Why study early human migration? Have you ever wondered where we came from? It's a question that has fascinated humans for centuries. We're all explorers at heart. We want to know our story. That's why studying early human migration is so important. It's like reading the first chapters of humanity's epic adventure. Fossil evidence is our time machine. It takes us back to when our ancestors first walked the earth. Each bone, each footprint tells a tale. It's a story of survival, of adaptation, and of incredible journeys. These ancient remains are like puzzle pieces. They help us understand how we spread across the globe. Why does this matter? Because it's our history. It tells us who we are and where we come from. Fossil treasures unearthing our ancestral journey. Fossils are the stars of our human migration story. They're like snapshots frozen in time. Each discovery adds a new piece to the puzzle. Let's look at some of the most important finds. These fossils have changed how we see our past.
First, there's Lucy. She's a 3.2 million-year-old Australopithecus afarensis. Found in Ethiopia in 1974, Lucy showed us our ancient roots. She walked upright but still climbed trees. Lucy proved that our ancestors were already on the move long ago. They were exploring new territories even before they were fully human.
Then there's the Turkana boy. This nearly complete skeleton was found in Kenya. Africa, the cradle of humankind. Africa is where our story begins. It's often called the cradle of humankind. This isn't just a saying, it's backed up by solid evidence. The oldest human-like fossils have all been found in Africa. This continent was home to a diverse family of early humans.
In East Africa, the Olduvai Gorge is a treasure trove of fossils. It's in Tanzania. Here, Louis and Mary Leakey made groundbreaking discoveries. They found remains of Homo habilis, one of the earliest members of our genus. These fossils are about 1.9 million years old. They show that early humans were using stone tools.
South Africa has also yielded crucial evidence. The Cradle of Humankind World Heritage Site is near Johannesburg. Out of Africa, tracing the path of early humans. The Out of Africa theory is a cornerstone of human migration studies. It suggests that all modern humans descended from a population that left Africa around 60,000 years ago. But the story is more complex than a single exodus. Evidence shows there were multiple waves of migration.
The first migrants were likely Homo erectus. They left Africa about 1.8 million years ago. Fossils found in Dmanisi, Georgia support this. These 1.8 million-year-old remains are the oldest human ancestors found outside Africa. They show that early humans were already explorers, venturing into new territories.
Later migrations involved our own species, Homo sapiens. Fossil evidence from Israel's Mislia cave dates to about 180,000 years ago. This suggests that modern humans left Africa earlier than we thought. But these early ventures didn't lead to lasting populations outside Africa. The main Out of Africa event happened around 60,000 years ago. Section 5, Asia, a new home for ancient wanderers. Asia played a crucial role in early human migration. It was both a destination and a launching pad for further journeys. The fossil record in Asia is rich and diverse. It tells a story of multiple human species living side by side.
One of the most exciting discoveries in Asia is the Peking man. These fossils were found in Zhoukoudian, China. They belong to Homo erectus and are about 750,000 years old. This shows that early humans had already reached East Asia by this time. They had adapted to new environments far from their African origins.
Southeast Asia has also yielded important fossils. On the island of Flores in Indonesia, scientists made a surprising discovery. They found remains of a tiny human species. It's called Homo floresiensis, nicknamed the Hobbit. These fossils are about 60,000 to 100,000 years old. Section 6, Europe, the last frontier of human migration. Europe was one of the last continents reached by early humans, but once they arrived, they left a rich fossil record. This evidence tells a story of resilience and adaptation. Early humans in Europe faced harsh Ice Age conditions, yet they thrived.
The oldest definitive evidence of humans in Europe comes from Spain. In Atapuerca, scientists found fossils dating back 1.2 million years. These belong to Homo antecessor, an early human species. This shows that humans reached Europe much earlier than we once thought. They were already adapting to cooler climates.
Neanderthals are a crucial part of the European story. They lived in Europe and parts of Asia from about 400,000 to 40,000 years ago. Fossils of Neanderthals have been found across Europe, from Gibraltar to Germany, from Wales to Croatia. Section 7. The Americas. The final destination. The Americas were the last continents to be reached by humans. This makes them crucial for understanding the final stages of early human migration. The fossil record here is more recent but no less fascinating. It tells a story of rapid adaptation to new environments.
For a long time, the Clovis culture was thought to represent the first Americans. These people lived about 13,000 years ago. Their distinctive stone tools were found across North America. But newer discoveries have pushed back the date of human arrival in the Americas.
In Monteverde, Chile, archaeologists found evidence of human presence dating back 14,500 years. This site includes preserved footprints, tools, and food remains. It shows that humans had already reached the southern tip of South America by this time. This means they must have arrived in North America even earlier. Section 8. Dating the past. How scientists uncover ancient secrets. Understanding when fossils lived is crucial to tracing human migration. Scientists use several methods to date fossils. Each method has its strengths and limitations. By combining different techniques, researchers can get a clearer picture of the past.
Radiocarbon dating is one of the most well-known methods. It works for organic materials up to about 50,000 years old. This method measures the decay of radioactive carbon-14 in once living things. It's very precise for more recent fossils, but it can't be used for older remains.
For older fossils, scientists use other radiometric dating methods. These include potassium-argon dating and uranium series dating. These methods can date rocks and minerals associated with fossils. They work on much longer timescales, up to billions of years. This is crucial for dating our earliest ancestors.
Sometimes fossils can't be dated directly.
Section 9. Piecing together the puzzle. From fossils to migration theories. Fossils are like pieces of an ancient jigsaw puzzle. Each one gives us a glimpse of the past. But to understand human migration, scientists need to see the bigger picture. They do this by combining evidence from many fields of study.
Paleoanthropologists study the fossils themselves. They look at the shape and size of bones. This can tell them about how our ancestors moved and what they ate. It can show how they were adapted to their environment. This helps trace the path of human migration across different landscapes.
Archaeologists study the tools and artifacts left behind by ancient humans. Stone tools are especially important. They can show how technology spread and changed. This helps track the movement of people and ideas. For example, similar tool types found in different regions suggest contact or migration. Section 10. The DNA connection. Genetics and human movement. In recent years, DNA has become a powerful tool for studying human migration. It's like a genetic time capsule. Our DNA carries traces of our ancestors' journeys. By studying it, scientists can trace ancient population movements.
Mitochondrial DNA is especially useful. It's passed down from mother to child. Scientists have traced it back to a common ancestor. She's called Mitochondrial Eve. She lived in Africa about 200,000 years ago. This supports the out-of-Africa theory of human origins.
Y-chromosome DNA tells a similar story for paternal lineages. It's passed from father to son. Studies of Y-chromosome DNA also point to an African origin. They show how male lineages spread across the world. Section 11. Rewriting history. The impact of fossil discoveries on our understanding. Fossil discoveries are constantly changing our understanding of human history. Each new find has the potential to rewrite the textbooks. It's an exciting time for the study of human origins and migration. New technologies are revealing secrets hidden for millennia. Recent discoveries have pushed back the dates of key events. We now know that modern humans left Africa earlier than we thought. We've learned that different human species coexisted for long periods. This paints a picture of a more complex and diverse human past. These discoveries have broader implications. They show that human history is not a simple, linear story. It's a complex web of migrations, interactions, and adaptations. This challenges simplistic ideas about race and human differences. It shows that we're all part of one diverse human family,